All right, we're talking proportional reasoning today, so we're going to start just talking about proportions. Um, to that end, proportions are a way for us to make comparisons between two ratios. So if I have one ratio and I know that it has the same setup as another ratio, I can set those two equal to each other. And in the big picture, there are four pieces in our proportion. If we know three of the four pieces, we can find the fourth piece. A little bit of review. This may be familiar for you. If that is, that's great. If it's not, please don't hesitate to ask any questions that you have. But if we have a proportion, say 2/9 is equal to x over 15. And we'll work on problems where we get to where we're setting up a problem that would look like this. For right now, we're just going to solve this proportion that is 2/9 equals x over 15. To solve this, anybody remember what it's called, what the process is called? It's not important that you remember, but I figured I'd give you a chance to tell me. Excellent, Natalie. Very good. And if anybody else knows, it's fine for you to type it in. It's okay if the same thing gets typed half a dozen times by different people, there's nothing wrong with that. It lets me know that sort of we're all on the same page together. Anyway, cross multiply is exactly right. We're going to multiply this direction and multiply this direction. And when we do that, that's going to set up an equation for us that we can solve. And so x times 9 will give us 9x. Going the other direction, 2 times 15 will give us 30. And so we have 9x is equal to 30. We need to solve that. And we won't do a ton of algebra in this class, but just a little reminder of algebra. I've got 9 multiplied by x here. What do I want to do to make that multiplication go away? What's the operation I want to do? Excellent, Zara, Nicole, Emily, perfect. We're going to divide, and we're going to divide by 9, because when we divide by 9, that's going to make these 9s cancel, leaving just the x, which is what we're after when we're trying to solve the equation. We want to get x by itself. Of course, if I divide by 9 on the left side of the equation, I also have to divide by 9 on the right side of the equation. And so over there, we have 30 divided by 9, which is 3.333333. This goes on. We were told in the problem, I didn't really read it back then, but for the example below, we're going to round our answer to the nearest 100. So to round to the hundreds place, first we'll find the hundreds place. That's 2 past the decimal. We'll look one space to the right of there. If that number is 5 or bigger, we round up to 3.34. Since it's 4 or lower, we're going to round this down to 3.33. So solving for x here, we would get 3.33. Let me know if you have any questions on that. And we'll address those. Basically, that is how we will solve proportions. Now, we're going to see proportions in a lot of different structures, a lot of different situations. But eventually, we're going to get ourselves to here where we have one ratio equal to another, and we're going to use cross multiplying to solve. Here's a problem I'll just kind of throw out there for you. A store sells laundry detergent in a small 36-ounce bottle for $2.99 and a large 48-ounce bottle for $3.79. Which is the better buy? I'm going to give you a minute. I'm not going to do a poll for this. Oh, you know what? I could do a poll for this. Yeah, I will. I'll do a poll for this. So basically what we're after here is, which is the better buy, the large or the small? There we go. So which is the better buy, large or small? Now, keep in mind, I haven't told you anything about how to solve this problem. So essentially, you're kind of flying blind. You're on your own a little bit here. If you remember the beginning of Math 122, there were some problems in there where we were kind of, we're figure out a method and then solve it. What's beautiful about that is, or let me start the other way. What's challenging about that is you might not know exactly what to do. What's beautiful about it is the way you approach this might not be the same as the way somebody else approaches this. And that's perfectly fine. As long as your method is valid, then your method is okay. I'll be curious to ask a couple of you how you went about getting your answer to this one. Um, and I know it may not be the easiest thing in the world to type. If you wanna turn your microphone on, you can. If you want to type it, you can. But and if you're just a little camera shy or typing shy, that's okay. I'm not gonna force anybody to tell us what they did. I'm just curious to hear what it is that you did to make a decision for this one. I think there are a couple different ways you can go. Let's go maybe another 30 seconds and then we'll talk about it. Oh, I don't know if we've done a poll before. Some of I kind of took it for granted that a lot of you that are in my Math 122 last semester would be very familiar with the idea of a poll. What happens when I make a poll is it's a chance for you to practice a problem. And so here's a problem, you can work on it, and then a list of multiple choice options will pop up on your screen, and then you can choose the one that you think is correct for this. I love the polls. I think they're fantastic. They give you a chance to practice in a, I'd say low stakes, but there's actually no stakes environment where you just get to try it and see, were you able to solve this? And then it also gives me some feedback on where are you as a class related to this particular topic. So we'll use these quite a bit in our class meetings. It's a way for me to get feedback and for you to practice problems. So if you hadn't seen polls before, I apologize for taking that for granted. All right, let's go ahead and take a look at our responses to this one. Now this one, we didn't do any prep. So it's perfectly reasonable for you to not know what to do on solving that one. But we do have pretty strong agreement on there, with large being the most common answer. Doesn't necessarily mean it's correct. Often it does, but not always. So somebody who was comfortable with this, if you would let me know how you decided you got your answer, and we'll just kind of, we'll kind of limp through this a little bit because it might not be polished or perfect. But I'm just curious what you did to get the answer. Natalie, divide the ounce by the price. And so it's how many ounces for the price. That's excellent typing, Natalie. I mean, this is a hard one to kind of phrase. And this is an approach that a lot of people probably took, was I'm going to take the ounces and divide by the price. So let's see. That means for the small, I'm doing 36 ounces divided by $2.99. What I'm finding out here, if I do this approach, is I'm finding out how many ounces do I get for every dollar that I spend. That's a unit price. That's exactly what we're working on here, is unit pricing. How many ounces do I get for every dollar that I spend? 36 divided by $2.99. And I'm getting, this way, I'm getting 12.04 ounces per dollar. This may be the same thing that a lot of you did. And if you did, great. Now we look at the large. And over there, we're doing 48 ounces for $3.79. We're going to do the same thing. We're going to divide to see how many ounces I'm getting per dollar. When we divide those, what we're finding out then is ounces per dollar. I want to mention the word per, because ounces per dollar, that's exactly what we have here. Ounces per dollar. The word per is sort of an indication that we're dividing. So we do 48 divided by 379, and I get 12.66 ounces per dollar. Well, when I buy the small, I'm getting 12.04 ounces per dollar. If I buy the large, I'm getting 12.66 ounces per dollar. I'm getting more ounces per dollar if I buy the large, so the large is the better buy. One thing I do want to say, you could absolutely do this the other way around. If you did dollars divided by ounces, let's take a look at that. What if you decided, you know what, I'm going to do 299 divided by 36 and find out how much am I paying for every ounce? That would be perfectly fine. You do 299 divided by 36 and you get, okay, Edison did dollars per ounce. Perfectly fine. Completely reasonable way to go. And there you get 0.083. We'll go ahead and go to the thousands place because this might be pretty close. And so you're paying 8.3 cents per dollar. Now, I'll look at that one in just a minute, Lorraine. Let me do this the other way over here. And so we'll do 379 divided by 48. So now we're figuring out how much are we paying for every ounce. 379 divided by 48, and I get 7.9. Oops. So over here, I'm paying 8.3 cents per ounce. Over here, I'm paying 7.9 cents per ounce. This is the cheaper, we get the same result. We better get the same result. You know, we want our outcome to be valid. And so either of those approaches for unit pricing works. Ounces per dollar or dollars per ounce. All right, let me see what you've got there, Lorraine. 36 divided by 3. Okay. Oh, interesting. Okay, so what Lorraine did there, and you correct me if I'm wrong, Lorraine, is you said, you know what? I'm getting 36 ounces for $3. And over here, and if I do that, then I'm basically paying $1 for every 12 ounces. And $1 for every 12 ounces, to get a 48 ounce bottle, I would have to multiply this by 4 to get 48 ounces. And I'd multiply this by 4, and that would be $4. So at this price point, I would be paying $4 for 48 ounces. Instead, I'm only paying $3.79. Since I'm only paying $3.79, this one is a better deal. Fantastic. All three of those methods, they work, they're great, and they're all valid. Again, we did it at the beginning of 122. We kind of looked and saw there's a lot of different ways to solve problems that are valid. And it's okay to use different ways to solve problems as long as what you do is valid. That's something that I want to encourage in our class, and probably more importantly than that, I want you to encourage it when you go out and you're in the classroom. Sometimes, you know, it's hard. You try to anticipate what a student's going to do. Like the first time you teach a topic, it's really hard to know, like, oh, did that work? Is that going to work every time? You know what? I'll get back to you, Susie, and I'll investigate that a little bit and see if it'll work every time, rather than just saying, no, do it the way we do it. Encourage creativity, I guess, is what I'm getting at, and I'll try to do that too. All right, let's take a look at one other way to look at this. It's very similar to what Lorraine did. If we wanted to use a proportion for this, and again, this isn't the way you have to do it, but it's another approach you might use. If our 36 ounce bottle costs $2.99, and we set that up as a proportion, our 36 ounce bottle costs $2.99, and then the way I'm going to set up my proportion then is, okay, a 48 ounce bottle would cost how much if it was going to be priced at the same rate? This is very similar to what Lorraine did. Lorraine didn't do it by setting up a proportion directly, but it's very much what she did. And essentially what we're doing here is we're setting up a proportion. 36 ounces for $2.99. Okay, what would the cost be for 48 ounces at that same rate? And so we have a proportion that we can solve. We'll cross multiply. And when we do that, we'll have, let's see here, 48 times 299 is 143.52. The other way, 36 times x is 36x. If you see something that doesn't make sense, you're not sure where the numbers came from, please don't hesitate to let me know. We'll divide by 36 to get the x by itself. We'll also divide by 36 over here. On this side, those cancel, leaving us just the x. And on the other side, 143.52 divided by 36 is 3 point, if we rounded to the nearest hundredth, it'd be 399. So, very similar to what Lorraine did. If 36 ounces cost $2.99, at that same unit pricing, 48 ounces would cost $3.99. Since we're getting it for $3.79, the large bottle is the better deal. Any of those ways to solve this is great. I would never think of using a proportion to solve this one, so I kind of wanted to show you how you could. Are there any questions on that before we go forward? All right, some more direct proportion type problems are something like this one. It's been estimated that every 2,000 pounds of paper that is recycled saves about 16 trees. If a college recycled 8,000 pounds of paper during a semester, how many trees did it save? This is very much a proportion type problem. We have, and the way to recognize that is 2,000 pounds corresponded to 16 trees. 8,000 pounds corresponds to how many trees? So it's very much a straightforward proportion type question. And you could set this up a couple of different ways, but I tend to kind of just work with what the problem gave me, and I'll go with, okay, well, 2,000 pounds for 16 trees is equal to 8,000 pounds for how many trees? The thing we don't know we'll call X. I will say, if you wanted to set this up as 16 trees, 2,000 pounds is, I don't know how many trees, 8,000 pounds, you're going to get the exact same answer. You just want to make sure that when you set up your proportion, you do it in a way that is logical, that the corresponding pieces make sense. Let's go ahead and solve this one. We'll cross multiply. And when we cross multiply, we'll get 8,000 times 16 is 128,000. Kind of a big number, but that's all right. We're allowed to use calculators. And the other way, 2,000 times x. Oops. Finally, we'll divide both sides by 2,000. On the right side, those cancel, leaving the x. We also have to do the same thing to the left-hand side. And when we do that, we'll get x is equal to 64. So 8,000 pounds of paper recycled would save 64 trees. Does anybody have questions on that before I have you try one? Okay. I got to tell you, this new reaction thing, it used to be just raise your hand. Now the reactions, I have to remember, like, what's going on over there? But now it's perfect. It's great. It lets me know that you know that we're good. Move on. Awesome. Okay. One for you to try. It's been estimated that every 2,000 pounds of paper that is recycled saves about 16 trees. If a college recycled 13,250 pounds of paper, how many trees did it save? Round to the nearest whole number. I'm going to set up a poll for this one. And we'll have you try it. So essentially this one is about being careful when you set up a proportion and then using cross multiplication to solve. We'll go another, I don't know, 20 seconds on this, and then we'll talk about it. See where we are on this one. All right. Not unanimous, but very close. Oh, I'm sorry, Zara. I guess it just kind of depends on the screen and where it pops up because it sometimes it's in a different place. So that may have been why you didn't, why that may have been our only dissenting answer here. We'll see. All right, so we'll go ahead and work this one through together. Let me know if you have any questions. So as we saw before, 2,000 pounds corresponds to 16 trees. So 1,250 pounds corresponds to how many trees? We'll cross multiply. And so we'll have 16 times 13,250 is 212,000. And that's going to be 2,000x. We'll divide both sides by 2,000 and get 106. No rounding necessary because our answer came out to be right there at the whole number. Let me know if you have questions on that. Otherwise, we'll go ahead and go forward, and I'm going to have you try another one. A 3-foot tall dog casts a shadow that's 8 feet long. At the same time, a tree casts a 30-foot long shadow. How tall is the tree? Rounded to the nearest hundredth. I am going to set up a poll for this one. The reason for at the same time, it's not to make this tricky or anything like that. It's just the sun is at the same place in the sky, so the angle of the sun coming down is the same. So that tells us that it's reasonable to use a proportion to solve this. I'll set up a poll for this one and give you a shot to try. We'll go another 20 seconds and then talk about this one. See how we're doing? Not unanimous, but close. Definitely strong agreement. That's a good thing. If you don't see where your mistake might have been when we go through this, don't hesitate to ask. So here I have a 3-foot tall dog and an 8-foot long shadow. You don't have to set it up this way. There are other ways you could set it up that would make sense, but I'm going to go ahead and put my height of the dog over the length of the shadow. And then for the tree, it'll be the height of the tree over the length of the shadow. Again, you just want to make sure you're being logical with your setup. So here I have height of the dog, length of the shadow, height of the tree, length of the shadow. When we solve, we'll cross multiply and have 8x is equal to 3 times 30 is 90. We'll divide both sides by 8 and wind up with x is 11.25. This problem told me to round to the nearest hundredth, and I already am. So we're at 11.25. Let me know if you have any questions on how we got there. Lorraine asked about number 23 from the homework. We may take a look at that after we get done with class today. And who knows, you might see something in class today that helps you answer that one. We'll see. Speed. It took Renee 24 minutes to go 15 miles. What was her speed in miles per hour? Now, this one right out of the gate, you might think maybe I could do this with like dimensional analysis where we set up that scaffolding, and that is possible. But honestly, instead here, we can think this through and say, okay, it took 24 minutes to go 15 miles. So 24 minutes to go 15 miles. Here's where we have to be careful. What was her speed in miles per hour? So we need to know how far did she go in an hour, right? So miles per hour is how far in 1 hour. We've got to be a little bit careful here because as I go to set this up, what I might do is, okay, 24 minutes, 15 miles. So 1 hour is how many miles? Why is that no good? Excellent, Lorraine. Very good, Nicole. Because up here, my units are in minutes. So I don't want to change this one to hours. That's going to give me a goofy answer that doesn't line up with what I'm after. Instead, I do want 1 hour to be up here, but just like Nicole said, I need to write it in minutes, not hours. So when I do this, I'm going to call it 60 for minutes, and I don't know how many miles. So if it's 24 minutes for 15 miles, then I want 60 minutes for how many miles. Really easy to drop a 1 in there because it's 1 hour, and that's where the time went, was on the top. But instead, we want to do 60 for those 60 minutes, because that's how we're going to use the 1 hour in this problem because we're working in terms of minutes. Now we've got a proportion we can solve. We'll cross multiply. 60 times 15, 24 times x. You're going to be really good at cross multiplying by the time we finish this section. Now we'll divide both sides by 24 and find out that it's 37.5 miles in an hour. So what we're saying here, we don't want to lose sight of the problem we just solved. Renee goes 15 miles in 24 minutes. What's her speed in miles per hour? How many miles would she go in an hour? 37 and a half. We kind of want to make sure our answer makes sense here before we put it to bed and say, all right, well, she went 15 miles in a little less than half an hour. So she's definitely going to go more than 30 miles when this hour is complete. And sure enough, that's what we got. So it doesn't mean our answer is correct. It just means it's reasonable. I want you to try one like this. You travel 18 miles in 34 minutes. What is your speed in miles per hour? And round your answer to the nearest tenth. I'll make a poll for this one, and we'll see how we're doing with it. We'll go another 20 seconds on this and then talk through it. See where we are. Not unanimous, but close. Kind of where we've been mostly today is not unanimous, but definitely strong agreement. Let's go ahead and look at it. You let me know if you have any questions, if you don't see where anything came from. So in this particular setup, we went 18 miles in 34 minutes. So I'll just do 18 miles on top, 34 minutes on the bottom. What is the speed in miles per hour? And so how many miles in 1 hour, but we want to be careful here and call that 60 minutes because our problem's in minutes. Now you'll notice this time the 60 is on the bottom. That's just because the way the problem was written. Last time it said minutes first and miles second, so I put the minutes on top and the miles on the bottom. This time it said miles first and minutes second. So I put the miles first, I put the miles on top and the minutes on the bottom. But you could write it the other way. If you had 34 over 18 equals 60 over x, that's perfectly fine. Just make sure it's logical when you set it up. And then 34 times x will be whatever 18 times 60 is, 1080. And we divide both sides by 34 and get x is 31.7647, and that keeps going. So most of our problems have sort of landed really nice and neat today, but this one didn't. So we go back up and it says round to the nearest tenth. Just a little review of rounding. I don't want you to take rounding for granted. Rounding is something that is going to come up for us from time to time, and I want to make sure you're comfortable with it. And if you're not, I want you to ask about it. Round to the nearest tenth, so we find the tenths place. That's the one right next to the decimal on the right-hand side. We look one space to the right. If the number in that spot is 5 or bigger, we round up. If it's 4 or lower, we round down. This one is a 6, so we're going to round up, and we're going to wind up with 31.8 miles per hour as the speed. Let me know if you have questions on that. Otherwise, we'll go forward and look at another one. All right. On a map, 1 inch represents 24 miles. If two cities are 2.5 inches apart on the map, how many miles apart are they? So here again, we know this is a proportion problem because of the relationships we've been given. It's 1 inch is 24 miles, and 2.5 inches is how many miles? And so that's the proportion we're going to set up. 1 inch is 24 miles. 2.5 inches is how many miles? Couple of things I want to say here. Yes, you can use decimals if you want to. You could change that to 2.5 inches. But as somebody who teaches Math 122, I'd love it if you did it with the fractions. It's perfectly fine if you do it with decimals. I'm going to work through this with the fractions just so you see it. If you drop 2.5 in there and solve this thing and get the same answer as me, that's totally fine. I'm going to work through it with the fractions just so you see it that way. And so when we cross multiply here, I'm going to have 2.5 times 24 is equal to 1 times x, which is just x. So our solution is really just on the left-hand side of equals here. Okay, 2.5 times 24. So to multiply that, and I'm hoping that all this is like, oh yeah, I totally remember this. This 2.5, we're going to change it to a mixed number. To do that, we're going to go 2 times 2 is 4, plus 1 is 5. So that's going to be 5 halves that I want to multiply by 24, and that's going to equal x. Of course, now I have this 5/2 that I want to multiply by 24. It'd be great if I could write 24 as a fraction also. So that's 5/2 times 24 over 1. And now I can multiply. When we multiply fractions, we just multiply numerators, multiply denominators. So on the top, I have 5 times 24, that's 120. On the bottom, I have 2 times 1 is 2. And so I end up with 60 is equal to x when I finish by doing 120 divided by 2. So if those cities are 2.5 inches apart on the map, they are 60 miles apart. Like I said, you're welcome to do it with decimals if you want to, but I want to make sure that you see it done with fractions just so those fraction operations stay fresh in your head. I'm going to have you try one like this. On a map, 3/4 of an inch represents 48 miles. If two cities are 4.5 inches apart on the map, how many miles apart are they? I'll set up a poll for this. And again, you're allowed to use decimals if you want to. We covered fractions in 122. We also covered decimals in 122, so it's perfectly fine. Keep in mind the idea is the same. We've got a relationship here, we're setting a proportion, and we're solving. So the big idea is the same. The numbers are a little bit more involved here than we've seen before. We'll go another 20 seconds and then talk about this one. All right, let's see where we are on this one. Okay, strong agreement, but a little spread around. So let's be careful as we go through this one. So on a map, 3/4 of an inch is 48 miles. If you tried this with fractions, I applaud you for that. If you struggle with the fractions and you're taking a quiz or an exam, use the decimals, because there's nothing wrong with decimals. It's just good to get the fraction practice in, but I don't know that you want to do that in a situation where you're, getting graded. Okay, so 3/4 of an inch is 48 miles. 4.5 inches is how many miles? So that's the proportion we're going to set up. We're going to have 3/4 of an inch is 48 miles, and 4.5 inches is how many miles? I'll do it with fractions. I might do this one both ways, actually. I might do it with fractions first and then with decimals after, just so you can see it both ways. Okay, so if we're going to do this with fractions, we're going to cross multiply, and I'm going to have 4.5 times 48 is equal to 3/4 times x. I'm going to convert 4.5 over here. I'm going to convert that to a mixed number. And the way we do that, remember, is 2 times 4 is 8 plus 1 is 9. What we're saying is 9/2 is the same thing as 4 1/2. And if you think about that, that should make sense. 9/2 is 4 whole things and then a half more. And then that's going to equal 3/4 x. Okay, now I want to do 9/2 multiplied by 48 over 1, and that's going to be my 3/4 x. If you see something you're not sure where it came from or doesn't make sense, don't hesitate to ask. And let's see, I can do 9 times 48 is 432 over 2 times 1, and that's 3/4 x. So 432 divided by 2, so I have 216 is equal to 3/4 times x. All right, here's one I'm going to throw at you. I want to get that 3/4 to go away. I want to have x by itself. What am I going to do over here to get that 3/4 to go away? If you don't remember, it's okay, but if you do remember, I want to give you a chance to say it. And I guess there's two ways you could phrase this. Keep, change, flip. Divide 216 by 3/4. I agree with that. Keep, change, flip. That's interesting, Jason. Multiply by 4/3. And what Jason is saying, what Natalie is saying, what Zara is saying are all the same thing, right? We are going to multiply by the reciprocal of this 3/4. Dividing by 3/4 is the same as multiplying by the reciprocal of 3/4. And that's what we're going to do here. We're going to multiply by the reciprocal of 3/4, which will be 4/3. If we do that on the right, we also have to do that on the left. On the right-hand side, it's really nice. The 4's cancel, the 3's cancel, and I just have x, which is where I was headed. On the left-hand side, you could do this either way. You could do, 4/3 times 216 over 1. You could see if these will cancel at all, giving you a smaller number, but you don't have to. You can just do 4 times 216 is 864 over 3, and then we'll divide that and get 288. And so how many miles apart are they? 288. That was our most common answer. If there's anything in there you're not sure of, you want to ask about, please don't hesitate. A lot of nice fraction reminders that we did in there. We took a mixed number and turned it into an improper fraction. We multiplied fractions, and then we multiplied by the reciprocal to get the variable by itself. A lot of nice fraction reminders. I said I would do this with decimals also. So let's go ahead and take a look at that. If we're going to use decimals, we're going to say then, well, 3/4 of an inch. 3/4 of an inch, that's 0.75, and that's 48 miles. And they're 4.5 inches, so that's 4.5 is how many miles? Nothing wrong with decimals. Decimals are great. Okay, and so now we're going to go ahead and cross multiply. We'll get 4.5 times 48 is 216. On the right-hand side, we'll have 0.75 times x. I want you to see here that that's 216 equals 3/4 x, which is the exact same place we got to with fractions. It did take more steps. So Edison might be onto something there. And then we'll divide by 0.75 on both sides. And dividing 216 divided by 0.75 is 288. And so 288 miles apart. I want to make sure you can do the fractions. I'm perfectly fine with you doing the decimals. Okay, the next one is a little more complicated. So far, we've kind of gotten this routine of set up a proportion, cross multiply. This next one is pretty involved, I think. We'll see how it goes. There's one like this in the homework that I want you to be able to do comfortably. So we'll look at it here. A boat travels 12 miles per hour and a plane travels 16 miles per minute. How far does the boat travel when the plane travels 480 miles? Now you're thinking, well, we've been doing proportions all day, probably going to set up a proportion. And there are three numbers here, so maybe I just use these three numbers in a proportion and go with it. Little word of caution. If you look at this, we've got miles per hour and miles per minute, and you know, this one's about the boat and this one's about the plane. And so we don't have a situation here that lends itself really nicely going straight into a proportion. We are going to use a proportion, but we're not ready yet. First, we've got to make sure we understand the situation here. So I've got this boat that goes 12 miles an hour and a plane that goes 16 miles in a minute. And my question is, how far does the boat travel when the plane travels 480 miles? Okay, so what would be really valuable here for me is, how long was the plane flying? The plane goes 480 miles. My question is to myself is, how long is this? How long does it take for the plane to go 480 miles? Once I know that, then I can go back and use the fact that the boat goes 12 miles per hour. Now I know how long it was traveling, so I can figure out how far the boat went. But the first thing I've got to do is figure out how long that plane was flying. Okay, well, the plane travels 480 miles and it goes 16 miles per minute. So if I take the 480 miles, I know it goes 16 miles in 1 minute. So I'll just divide by 16. This is very similar to what we did at the beginning of class with the unit pricing. It goes 480 miles. Well, if it goes 16 miles per minute, I can divide those to figure out how many minutes it's been traveling. So we'll do 480 divided by 16 and find out that it's been traveling for 30 minutes. We can think that through for a minute, make sure it feels right to us. If it goes 16 miles every minute and it travels for 30 minutes, well, I just multiply those to find out how many miles it went. 16 times 30, sure enough, that's 480 miles. Okay, great. So the plane was flying for 30 minutes. So now what I know is the plane was flying for 30 minutes, and the question is, how far does the boat travel in 30 minutes? Now I'm at a place where I can set up my proportion, because what I have now is I have a boat travels 12 miles per hour. How far does it go in 30 minutes? So if it goes 12 miles in 1 hour, there's two ways you could set this up. 12 miles in 1 hour, how far does it go in 30 minutes would be, I'll keep Edison happy and do the decimals here. How far does it go in half an hour? Another way you could set this one up is you could say 12 miles in 60 minutes. How far does it go in 30 minutes. If you'd rather work with whole numbers, this is just fine. If you're okay with the 30 minutes being half an hour, then this way is just fine. Either one of those approaches is going to get you the right answer. We'll finish this and then I'll kind of talk back through it again. I'm going to do it both ways. So we'll cross multiply here, and I have 1 times x is 12 times 0.5, which is 6. So how far does the boat travel in the time that the plane goes 480 miles? The boat goes 6 miles. And then over here in the other way, we'll have 60 times x is 12 times 30, 360. Divide both sides by 60, and sure enough, we get that same 6 miles. It's important to see that both of these approaches are valid, and so either way will get you there to the same time. Oh, right, Lorraine, you're right. Once you get to this 30 minutes, once you know it's 30 minutes, if it's 12 miles per hour, then we're just cutting that in half to get to 30 minutes, so we could cut the distance in half to get 6 miles. You're exactly right. And really, that's what happens here when we're multiplying by 0.5. Yeah, we're cutting that in half. You're exactly right. Great number sense, Lorraine. Excellent. All right, I want to talk back through this one again. There's one in your homework that I want you to be able to practice. So we're not going to do a poll for this one. I want you to practice the one that's in the homework assignment for this. But what we did here was this. We read the problem and we might think, throw it in a proportion. But take a step back for a minute and realize, well, we don't have things that logically connect the way they did in our other proportion problems. So instead here, what we have to do is go, all right, what am I being asked for exactly? How far does the boat travel when the plane travels 480 miles? So the first thing I need to figure out is, how long does it take for the plane to travel 480 miles? Okay, well, 480 miles at 16 miles per minute, I'll divide those and find out it takes 30 minutes. Now I know, okay, my boat's going to travel 30 minutes. How far does it go? And that's when I can set up my proportion. The numbers were really nice here with the 30 minutes. If it had been like 28 minutes, then we definitely need a proportion rather than just cutting them in half. Lorraine's number sense is excellent. It worked out here because this was so nice and tidy. It's possible it's something more like 28 minutes where we definitely need to use a proportion. And with something like 28 minutes, it'd probably stay away from the decimal and just do it this way. I don't think that's an easy question at all. I think a lot of the proportion questions we work on are pretty straightforward. I don't think that one is. All right. Yeah, that one is a lot. I agree, Nicole. There's a lot going on in this one. We'll back it off a little bit for this next one. It's still a proportion question, but you have to read it really carefully. At what's the matter U, the ratio of males to females is 4-to-1. If there are 4,000 students at the college, how many of them are male? Right off the bat, you might say, okay, I've got 4-to-1 and I've got 3,000 students. So 4-to-1 equals 3,000 over X. I'll solve my proportion. But hold on a minute. We want to be careful and make sure we're reading this correctly. What they gave me at the beginning was the ratio of males to females. This 3,000 number here, that's the total number of students. So I've got this ratio of 4-to-1 that's about the males to females. This number is not about males or females. It's about the total. So these numbers, as written, don't allow me to set up the proportion I'm looking for. Instead, what I've got to do is sort of think this through and say, okay, wait a minute. I need a proportion that helps me, set up some kind of relationship with the total. Yeah. With the total. All right. So what I'm going to try to set up then is this proportion is going to help me over here, this males to females ratio. It's going to help me, but I have to keep the total in mind. Here's a question for you that you may get it right away. You may get it after we say it. But my question to you then is, what fraction of the students at this college are males? The way you answer that question is right here. What fraction of the students at this college are males? And if I was going to say X out of Y students at this college are males. Outstanding, Lorraine. Very good. It's 4 out of 5. Like, okay, my ratio of males to females is 4-1. What that means is for every 4 males, there is 1 female. And so what that means is 4 out of 5 students are male, or 4/5 of the students are male. And now I'm at a place where, okay, that first information I was given, the idea that the ratio is 4-1, there's nothing about the total student body in there. But I can get there by using this information to go one step forward and say, okay, then, if the ratio of males to females is 4-1, then that means 4 out of 5 are males, or 4/5 of the students are male. Now I can do my proportion. Since 4 out of 5 students are male, I know there are 3,000 total students, so how many of them are male? And what we've got here then is 4 students out of 5 are male, so how many out of the 3,000 total are male? This one's not nearly as challenging as the one before it, I don't think. This one, we just have to be careful when we read it, realizing that this is about males to females. This number is about the total. So I need to take this information about males and females and set myself up with something that's about the total. Now we can solve and answer the question. We'll go ahead and do that. Cross multiplying, we'll have 5x is 4 times 3,000 is 12,000. We'll divide both sides by 5 and get 2,400. So of the 3,000 students at the college, 2,400 of them are male. The key here is we were given information about males to females, but this number here was about the total. So we need to rewrite that in a way that works with something that's about the total. Okay, I think those last two were a little bit more challenging than most of the problems we did today. This one, especially challenging. This one, just be careful when you read it. A couple of things I want to mention. Notes about the homework assignment from 5.1. Number 16, just a tip on that one, is your answer is going to be in miles per hour. Number 18 is just a fact that's going to be useful in there. Many of you probably know this already. I apologize if I'm telling you something you already know, but you might need the fact that there are 128 ounces in a gallon to answer that one. Number 23, Lorraine brought this one up. This is like the pigs and chickens type of problem that we had at the beginning of Math 122, where we're going to use 2 equations and 2 unknowns and substitute. I don't mind sort of helping you set that one up if you want to, Lorraine, but with this in mind, maybe that's enough for you to practice it. And if y'all want to ask about it either by email between now and next Tuesday, or if you want to just ask about it next Tuesday, that'll be fine. Or if you want to talk about it now, Lorraine, we can do that. But I'm hoping that's enough of a hint to sort of get you going with that one. You're going to use 1 equation for the money and 1 equation for the questions. Finally, in number 31, the project is 3/4 done, and it needs to be 4/4 done. And you'll understand that when you read the problem. Basically, we're setting a proportion here, and we want to make sure we use the proper numbers when we set up that proportion. Let me take one quick look here.